They told us Mars was dead, dry, a frozen graveyard. But what if beneath its dusty crust there's a secret ocean locked in time, waiting for us to notice? Chapter 1. A silent planet, once full of storms. Imagine standing alone on a high ridge, surrounded by the rust-colored silence of Mars. The sky above you is a faded orange, and the air is still. Dust clings to your boots. In every direction, the landscape stretches flat and dry, like a planet frozen in time. But what if it wasn't always like this? Once, long ago, Mars may have been alive with motion. There were rivers carving paths through the land. Lakes shimmered in shallow basins. Storms swept across valleys, and snow fell gently from thick clouds. Some scientists believe it even had oceans-wide, deep bodies of water reaching across hemispheres. Of course, that sounds strange today. Mars seems cold, dead, and empty. But the surface tells a different story. If you look closely at satellite images, you'll find ancient riverbeds snaking across the plains. You'll see canyons that look like they were carved by flowing water. Dried deltas still hold the shapes of their lost currents. Something happened here, something big. So, the question is, where did it all go? For decades, scientists have been trying to answer that. We know that Mars once had an atmosphere thick enough to support liquid water, but over time, that atmosphere thinned out. The planet cooled. Whatever surface water it had began to disappear. Some of it escaped into space. Some may have sunk underground, and some just maybe froze into massive, hidden glaciers. This idea isn't new. We've known for a while that Mars has polar ice caps. We've seen them from orbit. They grow and shrink with the seasons, just like Earth's. But those caps are mostly made of frozen carbon dioxide, with only a thin layer of water ice beneath. It wasn't until recently that we started looking elsewhere beyond the poles, into the highland regions and mid-latitudes, where signs of deeper, older ice began to emerge. And that's where things started to get exciting. Using ground-penetrating radar and thermal imaging, missions like NASA's Mars Reconnaissance Orbiter have found layers of subsurface ice hiding just beneath the dusty crust. These ice deposits stretch across hundreds of kilometers, buried under only a meter or two of rock and regolith. They're not just scattered patches, they're massive glaciers, frozen in place for millions of years. But here's the part that caught everyone by surprise. The latest studies suggest that these Martian glaciers aren't just dusty mixes of ice and rock. They could be more than 80% pure water ice. That's a huge deal. On Earth, glaciers that clean and pure are rare outside of Antarctica. Finding that kind of purity on Mars means two things. First, it confirms that water once flowed freely across the planet. And second, it means this water is accessible. If future missions wanted to extract it, they wouldn't need to dig miles into the ground. It's right there, frozen, preserved, waiting. Just picture it, hundreds of billions of tons of frozen water, hidden beneath the surface of a dead planet. A resource so vast, it could support not just exploration, but actual long-term habitation. And yet, we've barely scratched the surface. What's even more fascinating is where these glaciers are found. They're not at the poles. They're located in areas that would have once been temperate, regions where ancient lakes may have gathered. Places like Deuteronolismense and Arcadia Planisharugged, fractured terrains that almost look like the foothills of forgotten mountains. In those regions, you can find signs of motion, evidence that these glaciers once flowed downhill, just like they do on Earth. They pushed rock in front of them. They carved valleys. They shaped the land. But then something changed. The planet cooled. The glaciers froze solid and stopped moving. And for millions of years, they've stayed like that unchanged, untouched. It's strange to think that Mars, the planet we've always seen as dry and lifeless, once carried so much water. Not just as ice caps, not just locked underground, but as entire river systems, flowing through wide valleys. And now, the remnants of those waters lie trapped in ice, like time capsules buried beneath red dust. The silence of Mars is deceptive. It hides the memory of motion. Every ridge, every crater, every scar on its surface tells a story of change, a story of climate, a story of a world that may not be so different from our own, if we look close enough. And that's what makes these glaciers so important. They're not just frozen water, they're frozen history, layers of ancient climate data, possible traces of past life, and maybe even more exciting potential tools for future survival. In the next chapters, we'll dive deeper into how these glaciers were discovered, why this new data from 2025 changed everything, and what it could mean for humanity's future in space. But for now, remember this: Mars might seem still and empty, but beneath that silence, there's a story waiting to be heard. One made not of dust but of water, frozen in time. Chapter 2: The Hidden Ice. New discoveries in 2025. Sometimes the most powerful discoveries don't begin with something dramatic. They begin with silence data, quietly collected, quietly reviewed, until someone sees a pattern others missed. In early 2025, a new analysis came out from a team of planetary scientists working with data from NASA's Mars Reconnaissance Orbiter and ESA's Mars Express. These spacecraft have been circling the red planet for years, scanning its surface and peering beneath, with instruments like SHARAD and Mars's advanced radar tools that can see through soil, dust, and rock. Their job: to map what lies beneath. And in that mountain of radar data, something extraordinary began to emerge. At first, it was just a few patterns long, linear reflections hidden below the surface, stretching across mid-latitude regions of Mars. These echoes suggested solid material below the ground, nothing unusual. But as more locations were reviewed, the signals became clearer, more consistent, and then unmistakable. These weren't random pockets of material, they were glaciers. Massive glaciers, some hundreds of kilometers long. They sat just beneath the dusty surface, covered by thin layers of regolith, like hidden rivers frozen in place. But even that wasn't the biggest surprise. When researchers modeled the composition of these buried glaciers, based on their radar strength, density, and thermal behavior, they found something strange. These formations weren't mixed with a lot of debris, as many had assumed. They weren't filled with layers of rock or volcanic ash. Instead, the signals matched what we see with relatively clean, compacted water ice. In other words, these glaciers could be over 80% pure water ice. That number changed everything. For years, scientists believed Mars glaciers were likely a mix of rock and ice, maybe 40% water content at most. That would make extraction hard and inefficient. But 80%, that puts them closer to Earth's blue glaciers, the kind we find in Greenland or Antarctica. It means this water isn't just present, it's accessible, valuable, and potentially usable in the near future. Suddenly, what seemed like a buried curiosity became something much more, a strategic resource. Think about it: frozen water ice, that close to the surface, spread across regions like Arcadia, Planitia, and Utopia Planitia. These aren't random spots, they're relatively flat, low-lying areas, ideal for landers and possibly future human bases. The European Space Agency had already marked some of these areas as potential landing zones. Now, they had another reason to look closer. But let's pause for a second and consider how much ice we're actually talking about. Some estimates suggest that the volume of this buried ice could be equivalent to all of Lake Superior, one of North America's Great Lakes. Imagine that, a freshwater lake buried on another planet, frozen into thousands of shallow layers, just beneath your feet, and it's been there for millions of years, locked away, preserved by the cold, protected by dust. This is more than just a technical discovery. It's a poetic one. It reminds us that Mars has not always been what it seems, that beneath its dry and dusty skin, something soft, cold, and essential still survives. But the real excitement isn't just about finding water. It's about what this water can do. If future missions can reach these glaciers, they won't just be gathering samples, they'll be testing survival. Water is life. It's air. It's fuel. Through electrolysis, it can be split into hydrogen and oxygen, creating both breathable air and rocket propellant. That means these glaciers aren't just ice. They're the foundation of a sustainable mission, a way to live off the land, rather than bringing everything from Earth. And then there's the scientific side. These glaciers are more than a resource, they're a record. Just like on Earth, layers of ice preserve history. On Mars, These frozen formations might hold traces of the planet's ancient climate, dust storms, volcanic eruptions, even impacts from space. All of that could be trapped in the layers, waiting to be read like pages in a frozen book. And if Mars ever had life, microbes, bacteria, even simple cells, this is where we might find them, preserved in ice, safe from radiation, hidden from time. It's a chilling thought, isn't it? For decades, we've sent robots to Mars to scoop its soil, drill into rocks, and sniff for chemicals. But the most important clues might be sitting quietly beneath layers of frost, waiting. Now, with this new understanding of just how pure and widespread the Martian ice is, we have a map, a guide, not just for where to land, but for where to dig, where to explore, where to dream. And the implications stretch beyond Mars. If a cold, thin atmosphere planet like Mars can hold this much water underground, what does that say about other rocky worlds? What about the Moon? What about Europa or Enceladus? What else lies frozen, waiting? In a way, this discovery humbles us. We've always imagined Mars as a harsh, dry wasteland, a place where hope is difficult and life is unlikely. But that vision is starting to change, quietly, persistently, layer by layer. And now, instead of asking if Mars ever had water, we're starting to ask a better question: how much of it is still there? The discovery of these glaciers is not the end of the story. It's just the beginning. In the chapters ahead, we'll explore what this means for the future of Mars exploration, how astronauts could one day live, work, and even grow food using this buried water supply. But for now, take a moment to imagine it. A vast, frozen ocean, quiet, ancient, hidden beneath the skin of a silent world, waiting not just to be studied, but to be part of something greater. Chapter 3: Why it matters. Science, survival, and the future. When we talk about water on Mars, we're not just talking about ice, we're talking about possibilities. Think about what water means on Earth. It shapes everything. It's the source of life, the engine of ecosystems, and the foundation of civilizations. Without it, nothing grows, nothing breathes, nothing survives. Now, shift that understanding to another world, a place where everything is harder, colder, and more distant. Suddenly, a buried glacier isn't just a geological feature, it becomes something else entirely. A key, a chance, a beginning. In 2025, when scientists confirmed that Mars holds vast glaciers made of over 80% pure water ice, it wasn't just another entry in a research journal. It was a signal, one that reached beyond labs and universities. It reached mission planners, engineers, dreamers, because if we ever hope to send humans to Mars, and not just for a visit, but to live, work, and build, we'll need more than courage. We'll need water, not just for drinking, though that's obvious. Water can be turned into breathable oxygen. It can be split into hydrogen, a powerful fuel. It can support agriculture in sealed habitats. It can protect astronauts from radiation. And maybe most importantly, it reduces the need to carry everything from Earth. Let's look at it practically. Launching 1 kilogram of anything into space costs thousands of dollars. Sending all the water astronauts would need for a multi-year Mars mission. That would be wildly expensive, maybe even impossible. But if water already exists on Mars and in a form that's accessible, then the equation changes. Suddenly, Mars becomes more than a destination. It becomes a place we can stay. And this is where the glaciers matter most. They're not trapped deep below the surface, like some underground aquifers. Many are only 1 or 2 meters down. That's shallow enough to reach with basic tools. It means future landers or rovers, or one day, human crews can mine the ice, purify it, store it, and use it. It means Mars can provide for us, at least in part. But the significance goes beyond survival. These glaciers also have a voice, scientific voice. Just like tree rings or ice cores on Earth, Martian glaciers hold a frozen record of time. Every layer of ice contains dust from past storms, ash from ancient volcanoes, and maybe even particles from impacts that happened millions of years ago. By studying them, we can learn how Mars changed, how its atmosphere thinned, how its climate cooled, and maybe even how long water lasted on the surface. This helps us answer one of the oldest questions in planetary science. Was Mars ever alive? We're not expecting to find fossils or giant creatures frozen in the ice, but we might find simpler things. Organic molecules, salts or chemicals that only form in the presence of life. Microbes trapped long ago, shielded from radiation by layers of dust and frost. If we find even a hint of that, it would change everything. We wouldn't just be studying Mars anymore. We'd be sharing the universe with it. And even if no life is found, these glaciers still carry enormous value. They re part of the Martian climate story, evidence of how a world can shift from warm to cold, wet to dry, active to still. That's important knowledge for a planet like Earth, which also faces its own climate challenges. But let's return to the future. Imagine a small Martian outpost. 4 or 5 astronauts working in a dome near Arcadia Planitia. Outside, the landscape is silent, red, and wide. Inside, they're running experiments, growing food in hydroponic trays, monitoring systems. Their oxygen comes from recycled air, their power from solar panels, and their water from the ground just beneath them. Each morning they use a small drill to access the ice. They melt and filter it, storing it in tanks. Some is used for daily life, some is broken into hydrogen and oxygen. Some even helps grow crops. It's not science fiction. It's science approaching readiness. NASA is already designing ISRU systems in situ resource utilization that can turn Martian ice into useful materials. These systems are still prototypes, but they're being tested right now, here on Earth, in analog missions. And Mars is just the first step. If we learn how to survive there, how to use what we find instead of bringing everything we need, then we unlock more than a planet. We unlock the rest of the solar system. Because what we practice on Mars, we can one day apply to Europa, or Titan, or beyond. Still, some people ask, why bother? Why go to such extremes for ice on a distant world, when there are so many problems here at home? It's a fair question, but the answer isn't just about water, or space, or science. It's about vision. Mars challenges us. It forces us to innovate. It pushes the boundaries of what we think is possible. Every rover we land, every sample we study, every new discovery like these glaciers, it reminds us that we are still explorers. It reminds us that the unknown is not something to fear, but something to seek. And in a time when many things feel uncertain on Earth, looking to the stars doesn't mean we're escaping. It means we're expanding, we're learning, we're dreaming bigger. That's why the discovery of these glaciers matters so much. They're not just frozen water. They're a symbol of what lies ahead, a quiet promise beneath the dust, a resource that connects science, survival, and the spirit of exploration. They remind us that even in silence, there can be abundance, that even in cold, there can be hope, and that even on a distant, lifeless world, something essential remains, waiting for us to find it. Chapter 4, The Cosmic Question. What else lies beneath? Let's stop for a moment and imagine something deeper. Not just a layer of ice beneath Martian soil, but something older, stranger, something that's been waiting, silently, for eons. Because when we talk about ice on Mars, the conversation always begins with water. But it shouldn't end there. What if these glaciers are more than just frozen molecules? What if they're hiding traces of something ancient, something we haven't even imagined? Mars wasn't always like this. Billions of years ago, it had a thick atmosphere. It had flowing rivers, vast lakes, maybe even oceans. Volcanoes erupted across the surface. The magnetic field was still alive, and in that early chapter, conditions weren't so different from Earth. So where did it all go? That question has haunted scientists for decades, and the glaciers, strangely enough, might hold part of the answer. Beneath their icy shells, there could be records of the planet's slow unraveling. Dust layers trapped between free cycles, showing us when the air thinned, when the winds shifted, when the water began to vanish. Mars doesn't have tectonic plates to recycle its surface like Earth does, so the ice becomes a kind of archive, quiet, untouched, but packed with stories. And there's more. Some researchers believe that under certain conditions, even now, pockets of briny liquid water might exist within or beneath the glaciers. That may sound impossibly after all. Mars is cold, far colder than Antarctica, but salts can lower the freezing point of water, add pressure from overlying ice, and just a little geothermal warmth, and the result could be something surprising. Liquid zones. Not lakes exactly, not rivers, but puddles of life-friendly water. It's a long shot, but on a planet like Mars, long shots are worth chasing. Because if there's one thing we've learned from Earth, most extreme places from subglacial lakes in Antarctica to salt caverns deep underground, this. Life is persistent. On Earth, microbes have been found in environments once thought completely sterile, trapped in ice for thousands, even millions of years. Still viable, still alive, barely, but alive. Could something similar exist on Mars? Could there be microbes, ancient and slow, frozen in time? Or could there be microbes that never stopped? It's not science fiction. It's science standing on the edge of something profound. Instruments like the Sherlock spectrometer on the Perseverance rover are already scanning Martian rocks for organic molecules. But ice cores from these buried glaciers could go even further. They might hold fragments of proteins, cell walls, or other signatures we don't yet recognize as biological, but someday will. And the implications, they're massive. Because if life ever existed on Mars, even the smallest microbe, it tells us that life is not a miracle unique to Earth. It's something that happens when the right conditions come together. And if it happened twice in one solar system, then it might be happening everywhere. It would mean that we are not alone. That planets like Mars are not just destinations. They are chapters in a larger story of life itself. But even if no life is found, no cells, no molecules, no chemical fingerprints, the glaciers still whisper of mystery. For instance, we still don't fully understand how they formed. Some are shaped like classic Earth glaciers, with ridges and flows. Others appear more like debris-covered ice sheets, frozen in place. Some may have formed when Mars' tilts changed, causing massive snowfalls. Others might be remnants of ancient ice caps, left behind as the planet dried out. Each glacier is different. Each one tells its own version of Martian history. And here's something even stranger. Some of them seem recent. There are glaciers on Mars that show very few impact craters, which suggests they're young, perhaps less than 1 million years old. That's recent in planetary terms. And it means that even today, Mars might still be evolving, still freezing and thawing, still active in its own quiet way. This changes the way we think about Mars, not as a dead rock, but as a sleeping world. A world that once breathed, and maybe hasn't stopped. All of this makes the question what lies beneath far more than just curiosity. It becomes central to the future of planetary science. In the next decade, space agencies are planning missions that might finally answer some of these questions. NASA is working on concepts for ice-drilling probes lightweight, autonomous machines that could penetrate the upper layers of Martian glaciers. ESA and Rescosmos have already sent instruments to scan for subsurface ice. Even private companies are designing hardware that could mine Martian resources, preparing for future crewed missions. And let's not forget China's growing Mars program. Their Tianwen-1 mission successfully reached orbit and deployed a rover. They're thinking long-term, and ice is part of that vision. Because everyone knows, if we want to stay, we have to dig. And as we dig, we might not just find ice. We might find ancient dust storms preserved like snapshots. We might find the chemical record of Mars' lost oceans. We might even find the seeds of something that began before Earth was fully formed. There's something powerful in that idea, that below the red dust, in a place colder than any place on Earth, there might be a memory of water, a memory of life, a memory of a world that was once warm, vibrant, and blue. And that memory isn't just for scientists, it's for all of us. Because when we search beneath the surface of Mars, we're also searching beneath the surface of ourselves. Our need to know, our hunger to explore, our willingness to face the void not with fear, but with wonder. So yes, Mars is distant. Yes, it's cold. Yes, it's silent. But silence is not the same as emptiness. And what lies beneath the glaciers of Mars may be more than water, more than molecules, more than ice. It may be the beginning of a new chapter, not just for science, not just for space, but for us. Chapter 5, A New Frontier. What happens next? So, where does this leave us? We've traced the ice beneath Mars. We've seen the numbers, the maps, the layered history. We've wondered about ancient climates, potential life, future missions, and everything that might be hidden under the cold surface. But now comes the hardest question of all. What will we do with what we've learned? Because knowledge alone is not enough. Knowing that Mars holds vast glaciers perhaps containing as much as 80% of the water ice once thought lost changes everything, but only if we act on it. And that brings us to the heart of this story. Choice. Do we choose to invest in this frozen frontier? Do we choose to send not just machines, but people? Do we choose to imagine a future beyond Earth, not just in stories, but in reality? Because for the first time in human history, we are standing on the edge of becoming an interplanetary species. That sounds like science fiction, but it's not. The science is real. The plans are underway. The only thing left is the will to continue. Mars is no longer a distant red dot in the sky. It's a place with valleys and winds and shadows. It has seasons. It has polar caps. It has resources. And yes, it has glaciers, frozen deep beneath the dust. These glaciers are not just symbols of survival. They are tools. They are hope. If humanity is to settle Mars, we will rely on them for drinking, for farming, for breathing, for building, and maybe even more than that, for remembering. Because exploring Mars isn't just about finding water or signs of life. It's about preserving meaning, about asking what we want to carry forward when Earth is no longer the only place we call home. Will we carry the mistakes that brought us close to collapse? Or will we carry something better? Curiosity, cooperation, and care. The glaciers of Mars are silent, but they invite us to listen, to imagine a future where a child is born on another world, where Martian soil is tilled for food, where humans walk not just to explore, but to build a new chapter of civilization. This vision might seem far off, but remember, less than a century ago, humans hadn't even broken the sound barrier. Now we land robots on distant planets with parachutes and retro rockets, and in just a few years, we may begin sending astronauts to orbit Mars, then land, then stay. The ice will be there waiting, silent, timeless. It has always been there, and maybe, just maybe, that's not a coincidence. Maybe Mars has been waiting for us all along. Waiting for someone to listen, to look closer, to believe that even a frozen desert can offer new beginnings. Because in the end, the real story isn't about Mars, it's about us, about who we become when we step beyond the world we know, about what we choose to seek, and what we choose to protect. So the next time you look up at the night sky and see that small red dot, remember, it's not empty, it's not silent, it's not dead, it's a mirror. And beneath its ice, under layers of dust and time, is the reflection of everything we might still become.